So with an oceanic divergent boundary, you have oceanic crusts right here, and they're moving away from each other. Okay, they're moving away from each other because below we have convection of magma in the mantle. And this convection current pulls the two plates apart, and the rising magma right here fills in the space here, creating new sea floor. So right here, there's new sea floor. And it actually, that rising magma also pushes the ends of these two plates here up. So it creates this shape here, like this. All right, and this is called the mid-ocean ridge. This whole thing right here, this is the mid-ocean ridge. All right, so this is oceanic plate. And this is an oceanic plate. All right, now a mid-ocean ridge is basically a long underwater volcanic mountain range, and the biggest and most famous one, the one that's talked about the most, is the Mid-Atlantic Ridge, separating the eastern hemisphere from the western hemisphere and separating and pushing them further and further away from each other, the continents. All right. And of course, all is taking place on top of the mantle. So that is oceanic divergent boundaries. We talked about this before. We've drawn this before. It should be pretty simple at this point. We're going to move on to continental divergent boundaries, which is a little bit more complicated. And so let's take it step by step. Our continental divergent boundaries. Okay, so we have the continent, all right, and we have this rising magma below it. Let me load this continental plate real quick. We have rising magma below it, and of course it's convecting, like it always does, all right, and this rising magma melts the crust. Melts the crust right here, and the convection of magma going to sideways here in both directions is pulling it apart. So this gets pulled apart this way, and it gets pulled this way, and it opens up a gap here. And this rising magma fills in that gap. Okay, fills in the gap. And then we have what looks like a canyon. It's slowly going to keep getting further and further apart, okay? And there's a volcano right here. There's magma coming out right here. Just like on the seafloor, you have magma coming out of a ridge. Here it's not a ridge because it's on continental plate. It's not creating a ridge. It's just creating a valley with volcanic openings here, okay? With volcanoes. And it slowly gets further and further apart. On average, about 5 centimeters a year. Sometimes it's been known during big tectonic events to move 8 feet in a single event. I believe there was one time that after a major earthquake, they noticed that there was a 15-foot movement, which is very rare, but it just tells you how powerful this tectonic force is. And eventually, it gets to look like this, where you have these two cliffs, okay, that used to be connected. They're separated apart, and this whole area here has been created. This is all new seafloor, okay? And, well, it'll eventually become seafloor because what this is doing, it's splitting the continent apart, and eventually as this grows, it'll spread and reach the ocean, and the ocean will fill in this area, okay? Creating a new ocean. If you look at a world map, you'll see that Africa has been split up numerous times. You already know Madagascar used to be connected, and that separated, and the ocean filled in that space. You had India used to be part of Africa, and it got split up, and now it's colliding with China, creating the Himalayan mountains. But you have rift zones, and this is called a rift valley. You have several rift valleys in Africa, and it's going to separate Africa into even smaller parts, and as it splits up, the ocean water is going to fill in there once the valley reaches the ocean. It's happened numerous times. If you look at Saudi Arabia, okay, or the Arabian Peninsula, you have the Persian Gulf, and you have the Red Sea. Those used to be connected, but they split apart. Now, if it's closer to home, you can look at the Gulf of California. Between Baja California and the mainland of Mexico, those Baja California and the mainland of Mexico used to be together. But there's a Rift Valley there that formed, and it split the two apart, and the ocean filled that area in, and it's continuing to split as we speak, and it will eventually help split part of California off, Southern California off from the mainland as well. All right. So these are both continental plates. This is called a rift valley. It's a valley that's formed and eventually gets filled with the ocean. And this will become the new seafloor. Okay? So we're done with divergent boundaries. Oh, and then don't forget that we have volcanoes here. Okay? There are volcanoes in the Rift Valley here. And there's ancient ones that are dormant because they're not over the magma. And they kind of eroded away. You'll see little hills by the cliffs. All right, and so these are volcanoes. Let me put that here. So now we are done with continental divergent boundaries and divergent boundaries overall. And this is the most important one to us because this is where we live. We live right next to transform boundaries. We're on the boundary. Transform boundaries, an example of one is the San Andreas Fault. All right, and what transform boundaries are is two plates that are next to each other, and they're moving alongside of each other. One moving one way and one moving the other. And what happens is they're moving alongside of each other, and they get caught. Okay, because they're not smooth like this. Let me draw this a little differently here so you can see what happens. All right, so one's moving this way, one's moving this way. Now you can see that it's not perfectly smooth and straight where they connect. And so as they're moving, they get caught. They get jammed up here and they create hills, okay, like the rolling hills we have here in San Jose. And once the pressure, there's so much stress building up that they can't hold, it's going to break, okay? It'll break where the boundary meets, where it's stuck, and cause an earthquake. Okay? So that's why we have a lot of earthquakes here. Alright? So this is a transform boundary.